Good morning to our lecturer, Madam Tari Alifa binti Daniel, and my fellow friend. Today we're gonna present our end of chapter 2 presentation for the course DGM 50122 Embedded System Application. So our presentation topic is temperature control system using PIC microcontroller.
Hello, my name is Muhammad JUMADIL bin ARFAH and my cut matrix is 07DEM23F1001.
Hello, my name is DARREL LOSIUS and my matrix number is 07DEM23F1012. So we begin with a system identification. A temperature control system is a built-in application designed to maintain a desired temperature in an environment. It uses sensor to monitor temperature and control heating or cooling device. A common example is a water heating process in an automatic water heater. So the main component of our water heater is temperature is microcontroller. This acts as the brain of the system, making the decision to turn the heater on or off. An example is the PIC 18F, which is often used in home and industrial automation application. Second is temperature sensor. For example, the LM35. This is a high precision analog sensor for checking and monitoring the water temperature in the tank. The third is actuator. Heater element heat the water to the set temperature. Pump or circulation motor flow or circulate hot water to a tank or pipeline. These components all work together as a team to ensure that the water is always at desired temperature. Without any one of them, the system can function properly. Okay, next let's look at how the system operates in four main phases: input, process, output, and feedback. The first one is input. The temperature sensor measures the current water temperature in the tank. Then the user set point set the desired water temperature like 60 Celsius. Then the process. The microcontroller receives the reading from the temperature sensor. The MCU compares the current water temperature with the temperature set by the user. Based on this difference, the MCU or microcontroller decide whether to turn the heating element and pump on or off. The third is output. The heater element heat the water as needed. The water pump or distributor distribute the hot water. The display or indicator show the current status as water temperature, heating mode, and power. Then lastly is the feedback. The temperature sensor constantly monitor the new water temperature after heating is carried out. The information is sent back to microcontroller. The MCU evaluates the difference between the set point and the actual temperature, then control actuator such as the heating element and pump as need. The cycle repeat until the water temperature reach and stabilize at the desired level. That's all from me. Thank you.
Now, I want to will present about real-time aspect, real-time operation of water heater temperature control system. The system of operation in real time because it needs to respond immediately to change in water temperature. The sensor readings are updated every few milliseconds. The microcontroller MCU constantly compress the current temperature which the set point and immediately controls the heating element and pump. Real-time response is essential to prevent the water from getting too hot and too cold, and to ensure stable and efficiency temperature control. For the example of the importance of real-time water heater, a temperature control system in automatic water heating delays in controls can cause the water to overheat, damage the tank or pipes and component, and compromise the safety and efficiency of the system. And now I want to explain about block diagram heater temperature. The water heater temperature control system operates as a closed loop control system. The process begins with the reference user set point is compared with the feedback received from the sensor. The difference error is processed by the control PIC microcontroller, which then sends as input signal to regulate the system heating element and pump. The resulting output, actual water temperature, is measured by the sensor LM35, completing the feedback loop for continuous real-time temperature adjustment. For the conclusion, the water heater temperature control system is a real-time closed-loop system where the PIC feedback from the LM35 sensor to automatically control the heater and pump to be maintaining and the water at the precise user-defined set point safely and efficiently. That's all for me. Thank you.